Hi, everyone. Thank you, IsraelClouds, and thank you, TeraSky, for having me. My name is Tsahi Duek. I'm a Senior Specialist Solutions Architect for containers working at AWS. I've been working in both sides of dev and ops and have experience in both groups of people and personas working in that area. And on my day-to-day job, I'm helping customers design and architect their cloud and containers environment. But before we dive into this session, in today's session's topic, I would like to open with a brief alignment about personas involved, because each persona has different responsibilities and goals, and it's important to make sure we are talking to the right persona. Usually we see three major personas, you can see here. We have the application developer, the DevOps engineer, and the platform engineering team. We start from the top. Application developer should focus on improving and building business features, delivering services or new products. They usually requires automation pipelines and focus on taking their codes and making sure it deploys in the right environment with the right configuration. For them, velocity of delivery is fairly high. DevOps team, on the other hand, they're focused on enabling those application developers. They work to define standard development stacks, build and delivery pipelines, and tooling to be used for developers. The velocity of delivery is usually medium in this case. And last, we have the platform builders or the platform engineering team, and they focus on building and enabling both DevOps and application teams. And their focus is on building platforms that has all the company standards, all the organizational standards incorporated in this self-service model. They will build automation and pipelines that will result in consistent environments to be consumed in a self-service manner by other teams. In this case, velocity of delivery is fairly low. In our talk today, we will focus on how you can build consistent production-ready environment with Amazon EKS using TeraSky solution, which is based on another project we announced last year called EKS Blueprints. Our main focus in this session will be about those two personas, the platform builders and the app DevOps. And so let's start with the beginning. And usually this is where you decide to use Kubernetes as your containerized, to run your containerized application. Soon after that, you usually become overwhelmed with the amount of tooling and the Kubernetes ecosystem has to offer. And this usually leads to a paralysis situation where you ask yourself, like, now what? What should I do? What tooling and configuration should I use to run production workloads on my cluster? So in the next couple of slides, I will try to describe the journey that we see most customers going through when they decide to use Kubernetes. And as always, and I hope this is the case of all of you, we start with the documentation, understanding every component in the system. We understand the benefit, the flexibility, the feature it provides, but soon after we realized it also involves complexity for provisioning, upgrading, securing, and scaling the cluster itself. And of course, this is where managed services such as Amazon EKS provide significant values. Amazon EKS provides secure, managed, and scalable solution for running your Kubernetes cluster on AWS. The next step, of course, is to have our worker nodes, our data plane, for our pods to have compute capacity to run on. Provisioning single instances, as you can see here, is not something that scales very well. Actually, nobody does that. And this is where other features such as Amazon Managed Node Group, Amazon EKS Managed Node Group can help you easily manage the compute capacity for your clusters. Node provisioning and lifecycle management are automated by this capability, which include spot support and interruption handling, multiple instance type support, auto-labeling auto-labeling the nodes for cluster autoscaler with the relevant labels for cluster autoscaler, support for incremental or batch upgrades, and many more features. On the other hand, we have a new project called Carpenter. Carpenter is another autoscaler for your compute capacity. for EKS is Carpenter is usually defined as just-in-time node scaler, open source by AWS. Instead of managing node groups, Carpenter calculates the needed capacity for the pending pods in the cluster and provision the right capacity just in time for those pending pods. Carpenter simplify the operation of leveraging spot instances, and all of this done without specifying any node type or node size, as if some of you might know from the Cluster Autoscaler project, resulting in a much more flexible configuration that can help you leverage many more instance types depending on the application needs. Up until now, we discussed about compute and cluster control plane, but it does not end up there. We also need to take into consideration how we consistently configure, deploy, and manage our cluster-wide add-ons. And cluster-wide add-ons are simply applications, another application that are deployed in the cluster that provide cluster-wide operational support for our business application to run on. An example might be the basic operational services add-ons such as Core DNS that supports service discovery, Amazon VPC CNI that supports pod networking, observability add-ons such as CloudWatch Container Insights and FluentBit for metrics and log shipping, or on the other end, you can use Prometheus agent to scrape metrics and set it to Prometheus. For load balancing, we have the AWS Load Balancer controller that can, of course, work in conjunction with Nginx Ingos controller and other GitOps add-ons such as Argo CD, other operation add-ons such as Secret Store, External DNS, and Set Manager are all relevant and needed to operate and run production workloads on our clusters. But as you might guess, this is not the last step. We also have to take into consideration multi-tenant support. We need to make sure we design our cluster to support multiple teams and users and provide a standard way for identity and access management for all the other teams. We should implement policies that based on team responsibility and requirements and make sure we create isolated logical separation in the form of namespace and permission for those specific namespaces. And as a final step, we need to make sure we can automate the creation of clusters and replicate the same configuration, whether it's dev, test, or production environment, or any other new environment that you create consistently with a low effort of using the same tooling. And if I summarize some of the challenges that we might face and cover what I've discussed so far, is how do I enforce standards and best practices across multiple clusters? How do I create boundaries between application team? How do I add new environments based on EKS clusters with just a few lines of code configuration? And how they use a single source of tooling to configure everything we've discussed so far. And I like this image to illustrate what I mean, because I feel it illustrates pretty well what we're trying to achieve, which is how do we get from the left side, from the messy side, to the beautiful tied together rope on the right side of this image. Or in tech words, in technical matters, how do I easily build new production environments with Amazon EKS and have it all the relevant configuration tied together in a cohesive way? This is where platform engineering team focus on creating self-service infrastructure as code components and composition to enable other teams in the organization. An example of such is EKS Blueprints. EKS Blueprints was built as an open source development framework, allowing you to programmatically build EKS-based environment using infrastructure as code of your choice and providing built-in best practices. It integrates with other Kubernetes tooling. It is fully customizable. EKS Blueprints today supports both AWS CDK and HashiCorp Terraform as infrastructure as code. For our today's talk, we'll focus on the Terraform side, and as Lev will demonstrate later on, this is how TeraSky built their own solution based on EKS Blueprint. Now, what do you get when you're using EKS Blueprint? What is the components of EKS Blueprint? So starting from the basic layer of components is the cluster and the compute capacity. It includes the Amazon EKS cluster configuration, such as cluster version, control plane logging, and all other stuff all other components you can configure for your control plane. It also allows you to create your data plane, your compute capacity for your cluster, whether it's AWS Fargate, Amazon EC2, using Amazon EKS AMI or Bottle Rocket, or any other combination of those. Next one, as discussed, is the add-ons. We need to make sure we are having a standard way of deploying all the add-ons we need in the cluster. EKS Blueprint support specific add-ons such as AWS Load Balancer Controller, Amazon VPC CNI, and others, but also created an option, a way to deploy a community-based add-on such as Cluster Autoscaler, Nginx, and Argo CD. Last, we allow partners and third parties to define their own add-ons based on our interface we've created. And as a top layer, and the last layer of this solution is basically to configure cluster access and permission management for users, roles, or group. It's totally up to the user. This has been abstracted in the form of construct called the team, which I will dive deep into in the next session, in the next slide, where team actually designed to provide a set of isolated boundaries between application deployed in the cluster. Now, what do you get when you define an application team with EKS Blueprint? So we have the AWS Cloud, and we have your cloud account, and we have the EKS cluster itself. When you use EKS Blueprint to create team, it first creates a namespace. You can configure the labels and annotation to be defined on this namespace. It also creates the resource quotas for the application and the components workloads that will be deployed in this namespace. This way you can limit the resource consumption for all the components in this specific namespace. It also creates a standard IAM role with specific Kubernetes RBAC permission for that specific namespace. This role can only be assumed by any user or role that you define in your configuration for that application team. Using this, you can make sure that no other team can access other team namespace and vice versa. And last, it can create IAM roles for service account that can be used by the actual components, SQL workload that's running on the clusters, and interact with other AWS services such as S3, RDS, or Autoscan Group in our example. One notable example of a solution that was built based on EKS Blueprint is data on EKS. Data on EKS allow customers to build data analytics, processing, and AI/ML workloads on Amazon EKS. I will pause a moment so you can copy the link here in case you want to dive deep into this project. I will share it in a chat later on as well. Now, before we continue to the second part, where I hand over to Lev the discussion about how TeraSky built their own solution based on EKS Blueprint, there's one notable, thing I want to call out, and this is the direction of V5 for EKS Blueprint. EKS Blueprint is an evolving project, and based on customer feedback, we understand that the first direction we took needs to be changed, and as a result, we are implementing a couple of changes in the next version, in the version number 5. In short, the direction of project going forward is to focus on building holistic solution while relying directly on community models for building Amazon EKS clusters and the data plane. More information can be found on this link here. And again, I will share this in the chat as well after my part of the session. To summarize the changes that will happen in V5, which are the notable one, is first, we are integrated directly with the community model of EKS. Instead of wrapping the community model for Terraform EKS, we will integrate it with directly, and by that, any other customers that already uses the well-known and well-used community model can be easily integrated with other features such as teams, permissions, and add-ons. We will also create a generic add-on model that will make it easier to build new add-ons, both for third parties, partners, and for your own customized solutions. And lastly, The team will be managing their own repositories, meaning we are decoupling the team construct from all the other stuff, all the other components we discussed so far, allowing you to consume it, as I said, regardless of using other components in the system. Now, I will hand it over to Lev, where he will present how TeraSky build their production-ready solution based on EKS Blueprints, and how it can easily help you create and build your cloud-based environments and other services that address observability, operational excellence, and reliability. Lev, the stage is yours. Thank you.
Let me share my screen now. Okay, so thanks again, Tsahi. Thanks a lot, IsraelCloud. I'll take one step back and talk about moving into a new house or a new apartment. Usually you will notice that 4 walls is not enough, right? You will probably at least need a bed because you want to sleep somewhere. You will probably would like to put a mattress on it and maybe pillows. Maybe stuff in kitchen, right? Even if you're single in Tel Aviv, you will still need refrigerator, most probably microwave to heat things after you freeze them. You will probably would like to have a table and a chair, so you'll have a place to eat. And those kind of must-have things in a home, in an apartment. Then there are nice-to-have things, right? Like you would like to have big TV, maybe dishwasher, maybe curtains. And 4 wall is not enough. And this is exactly the same story with EKS. We see a lot of customers that launch EKS, realize there's many more things that are required to make it production ready. And this is actually what we see every day. So I'm Lev, I'm CTO at TeraSky. I've been doing Linux sysadmin for more than 20 years. I've been HashiCorp ambassador for the last 3 years. And I work, as I mentioned, at TeraSky, and TeraSky is a global system integrator. We are very focused on AWS, HashiCorp, VMware. We are part of CNCF community. We have a lot of engineers that are CKA certified, and Kubernetes is really our focus. So, as I've mentioned, we work with a lot of customers, and all of them have this problem of launching EKS, realizing they need more to make it production ready. But the question is, what is production ready? So here's how we see it. First of all, you need to be ready to run workloads. And you probably can run pods when you launch EKS at first, but you will realize that if you want to have a storage or persistent volume for your workloads, you need to do additional steps. It's not coming out of the box with EKS. You can probably create service type load balancer, but this is not what you would actually do in your productions. You will probably expose it through ingress. So there are additional steps that you will need to do because it not come out of the box with EKS. This is the first part. The second part is be ready for day 2 operations, right? What kind of day 2 operations? So for example, troubleshooting. Your workloads probably will have problems, so you'll need monitoring, logging, maybe distributed tracing, and scaling, right? Most of the cloud native application by nature can scale out and scale down, and you want to have this ability with your cluster. So scaling is super important, and it not come out of the box with EKS. Third thing is you want to follow security best practices, meaning even if you don't have to be compliant with SOC 2 or PCI, you still want to have least privileged, limit the access, and have all kinds of AWS best practices. Now, this conversation was so common from our customers that we decided to build a solution. And the solution actually is available on a marketplace. And you will get, as part of this solution, Kubernetes infrastructure, observability, all of those things. And you get actually details on this page on what are the things that are available. So you can take it from the marketplace. But I wanted to share with you what we did, how we did things, and why we decided to do certain things. So if you want to build it yourself in your own environment, you will know how we did it and what the decisions that we took. So first thing is you probably don't want to reinvent the wheel. We definitely wanted to leverage community knowledge and expertise. So we decided to go with EKS Blueprints. And the reasons to do this were, first of all, ready to use add-ons. As Tsahi mentioned, you have a lot of pre-built things that you can just take from EKS Blueprints that will work. For example, EFS CSI, Calico for CNI. You can use Consul for service discovery. You can get KEDA for auto-scaling. A lot of things are available there. Second, the community of EKS Blueprint is alive, right? It's not something that is stale and outdated. You have about 1,000 forks. You have about 2,000 stars. You have more than 100 contributors. And the documentation is really good. You have a dedicated site for documentation. You have really good concepts that kind of explain the philosophy of what they were trying to achieve and how you can do that. And there's a lot of testable examples that you have in the repository, so you can actually try it yourself. But the more we work with EKS Blueprints, the more it felt that it's not enough. There were things that we had to build in addition to EKS Blueprints that just not part of the project by intention. So EKS weren't enough. We went beyond EKS. We use it as a basis and fundamentals for many of the things. And then we did a couple of additional things. And here are the main reasons or the focuses of what we wanted to achieve in addition. So one, we wanted to make sure that this is simple and opinionated. And I will explain all of those things in detail a bit later. We were aiming for maximum support, meaning maximum support from the vendor, from AWS, and maximum support from our capabilities as system integrator. And we really wanted to focus on industry and CNCF standards, and I will explain in a second why. And the most important is invest a lot of efforts in the integration, so the entire thing will feel like one solution and not just different things that were deployed and not working together. So in terms of simple and opinionated, first of all, our goal was that someone who will look at the code of this solution will understand quite fast what is being installed. This will allow this person to actually focus on a business and not on configuring for hours or days the Kubernetes or the blueprints. So he will be able very quickly launch additional clusters with whatever is required. The opinionated part are, for example, we decided to go with Terraform. As Tsahi mentioned, there are two options. You can go for AWS CDK or Terraform. We are partners with HashiCorp. We invest a lot of effort and we have a lot of knowledge in Terraform. So this was a natural choice for us. Another example for opinionated decision, we decided to go for node groups. There's option to go with Fargate. There's option to go with instances, but we pick something that we believe is the most field-proven, battle-tested solution. So this is why we went for the node groups. Maximum support coverage. So most of the things that we decided to take are AWS based. And again, you can do a lot of things, but if you really want to leverage AWS ecosystem, this is probably the best solution. You can go, for example, for Contour ingress. You can go for Nginx, which is very common. We decided to go with Ingress ALB. Same for the storage. You can use Longhorn by Rancher. You can use OpenEBS, but we decided to go for EBS CSI from Amazon and EFS to leverage this storage. Another thing is we wanted you to be focused on your business. So everything that we could and everything that was CNCF compliant, we just went with managed services from AWS. For example, managed Prometheus, managed Grafana, a managed OpenSearch by AWS. Everything you get as a service. Okay, the CNCF standards. What we did there is we wanted you to have increased portability. If tomorrow you decide that you want to have the same deployment on premise, you can easily take EKS Anywhere. You can take all of the projects that we deployed and you can leverage them on-prem. Most of them are deployable and available in CNCF community. We wanted to make sure that you can leverage the CNCF ecosystem. Some projects in CNCF assume other projects from CNCF are used in your environment, stuff like Prometheus, things like Cert Manager. This is why we took this approach to make sure that things that you will take in addition from CNCF will work in that environment probably very seamlessly. And we want to push for CNCF adoption. So the more projects we deploy as part of our solution, the more adoption they will get, the more stable they will become, the more people will be able to use them. So this was the idea. The last part is the integration, right? So an example is we deploy FluentBit and we deploy OpenSearch, but we also connect between the two with all the privileges, and we do it in least privileged manner. Same for Prometheus. We deploy Prometheus that actually sends the data to managed Prometheus that sends the data to managed Grafana and integrates with AWS SSO. Same for backups. We deploy Valero that actually backup to S3 and it's all configured for you. So going back to production ready in details now, not on a high level. What will you need? So you will need a storage. You will need ingress. You will need permission. Now, Tsahi mentioned it, and this one is important. Once you install EKS, it's only available for the person who installed the EKS. This is the only person who can work with this Kubernetes. You actually need to add additional people to a config map of AWS authentication to allow them to deploy stuff to this Kubernetes. There's the other type of permission when you want your workloads to actually access resources in AWS, like S3 buckets or Dynamo or whatever. So this is IAM role for service account. Those are super critical things that you will need to address to make your Kubernetes production. As we've already mentioned, monitoring and logging are important. Scaling is important as well. Most of our customers also add those critical components. Security. Under security, you will probably have a cert manager for certificates. You will have secret management and secret CSI to provide access to your secrets in form of environment variables or mounts, and backup with Valero. Most of our customers also leverage external DNS. So every ingress that you create will automatically configure a Route 53 so you can access the workload that you just deployed. So this is the solution that we currently build for our customers. This is what it looks like. You will have your AWS and EKS in it. Obviously, etcd that is deployed there will be encrypted with KMS. Carpenter will be deployed for auto-scaling. You will have EBS, EFS, and FS6 CSI. You will have Ingress LB. In addition, you will have IAM that is connected to cluster role and cluster role binding, so you will have access to the environment. Prometheus that is deployed inside of this cluster will be sending data to managed Prometheus that will be connected to Grafana. FluentBit that is deployed will be sending data to OpenSearch. Secret CSI will send data to, will be connected to Secret Manager and will also work with this Reloader project. Now, I don't know how familiar you are with this, but this is a very helpful tool. This is actually an open source project that can monitor secret or config map, and every time they're changed, it will actually do a rolling restart for deployment. So this way, every time your secret is updated, you can actually do an update for your applications. Secret Manager that will be working with AWS Certificate Manager, and external DNS that will be working with Route 53. In addition to that, as I mentioned, we have Valero by Heptio or VMware today that is connected to S3 bucket, AWS X-Ray for distributed tracing, UpMesh for service mesh capabilities, and we did one more thing for GitOps. We deploy FluxCD, which will monitor your ECR repository, and every time a new image will be created, FluxCD will actually update the Helm inside of the code commit or any Git repository that you have, and it will deploy it inside of the Kubernetes itself. So this is very, very convenient. Okay, so let's do a demo and hopefully it will work. So I'm using Demo Magic, and this is just to avoid typos. The environment is alive. It's just saving mistakes. First, let's update the kube config. Okay. And now let's take a look at the nodes that we have. And at the moment, we have only 2 nodes. Let me just first cancel the full screen here. Okay, so first is the Terraform TFRs. This is the simplicity we were aiming for, right? At a very fast glance, you can understand what we're deploying. We're deploying in AWS region in this specific VPC, this cluster from that environment. This is the DNS or the domain that we're going to use. This will be used for certificates and creating records. And as Tsahi mentioned before, these are our application team. This is the multi-tenancy. So we will have a front-end team with those users, and we will have backend team with those users. These are the capabilities that we are enabling. So I will have logging enabled, monitoring enabled, and backup enabled. Super simple at glance. Okay, now if I take a look at the namespaces, so you can actually see that I have FluentBit and Cert Manager, but this is the beginning of my multi-tenancy. This is what Tsahi mentioned before. I have backend and I have frontend that were created because I have those application teams. And we're actually leveraging already the new module that will be added as part of version 5 of EKS Blueprints. And this is very, very convenient. I will show you additional stuff that it creates. So first, if you take a closer look at the namespace itself, you can actually see that we have annotations that you can specify. So like team backend, you have labels that you can specify, and there are limit ranges. Okay, so kubectl get limit ranges. You can actually see that we have 2 for backend and for frontend. So here's the details of the backend, right? We actually have a maximum limits of CPU and memory, and we have configuration for a default CPU and default memory. And we also have resource quotas. So you can see that we have for backend and for frontend a resource quota. And the idea here, this is a multi-tenant cluster, right? And we want to avoid noisy neighbors. So this is how you can prevent single team destroying your entire cluster and stopping everyone from working. Additional thing that you have is cluster roles that are automatically created. So you can actually see we have backend team cluster role and front-end team cluster role. Now, this is, I think, one of the most convenient things that you get. You have this output that I initially intentionally exposed, that is called a backend auth config map role. This is the configuration that you can actually add to your AWS auth config map, so you can configure the access for the teams to the Kubernetes, right? Because this is not about the person who deployed the cluster, this is about the teams. And every team that you will create will actually have this block of configuration that you can just add to your config map in AWS auth config map that will provide this access. All right, so let's take a look at the pods that are currently deployed in our environment. We have FluentBit, Cert Manager, external DNS. We have Flux CD services. We have Carpenter, AWS Load Balancer, Secret CSI for AWS, EBS CSI. We have Prometheus, and we have Valero. Inside of our default namespace, we currently have nothing. So let's deploy something there. This is a super simple Nginx deployment. So this is Nginx deployment with pretty outdated image, as you can see, and we have a service that will be looking at this deployment. So let's deploy it. It's being deployed. As you can see, this will be running on that port. And by this point, the pods are probably running. Great, we have 2 pods running. Now let's deploy Ingress. And here, what you can see is that this Ingress will be listening on TLS, and it will be responsible for this host, 1.tscto.com, and it will just forward all the traffic from / to the Nginx service that we deployed. Now you can see standard annotations here that are saying where to deploy this load balancer and just how to tag it and what ports it's listening to. and most of them are very generic. So this is basically will work in any environment. There are no specific stuff like a path to ARN of my certificate or Route 53. There's only one important annotation. TeraSky is hiring yes apply today. Nothing will work without this annotation. I'm just kidding. So let's deploy this ingress. All right, so it was created. Let's take a look. Great. So now we have our ingress available. We can see the host and we can actually see the load balancer that was created, and hopefully external DNS did its job, and maybe even we have DNS propagated and it will work for us out of the box. Let's try to open this page. Okay, so we've got to the welcome to the Nginx over 1.ts.com. As you can see, this is a secured connection, so everything is working. Let's take a look at our configuration with the Route 53. Okay, so as you can see, this actually created a couple of records, right? You can see that it created the CNAME of 1.ts, it created this A record, and it created this text. And this A record is actually configured to send it to this alias, which is our load balancer. All right. Second important thing is our certificates. So if we take a look, we actually have two certificates. This one, which is star.tscto.com. So anything that you will create, ALB ingress will do auto discover, find a certificate that is matching it, and it will use it for TLS connectivity. And this one I created manually for the open search, and we will see it a bit later. Okay, now let's do the auto scaling demo. So this is Carpenter deployment. And as you can see, it has 0 replicas by default. And the only thing that we deploy is this container with a pause image in it. Basically, it does nothing. The only thing it does, it asks for 1 CPU. So let's deploy it. And now let's see how many pods we have running, and no surprises. If it has 0 replicas, we have 0 pods running. So we also have 2 nodes at the moment. Let's scale up this deployment. So I'm creating 3 replicas now. And if we take a look at the number of pods that we actually have a couple of them running and 1 in a pending state, because there was not enough space in the current nodes. So now if we check the number of nodes that we actually see that we have 1 additional node that is currently booting, 13 seconds. This is the capabilities of Carpenter that Tsahi was mentioning before that. So let's take a look at the monitoring capabilities in addition to the scaling, because now we kind of can take a look at different parts of it. I'm opening my SSO to AWS page, and this is part of the integration. You can actually see that I have my accounts here, and I also have a link to my Grafana here with single sign-on. So if I click on it, I actually get managed Grafana, and there's a couple of things that we did with the automation, and actually Terraform was very, very helpful here. One is we automatically provision data source. So you see this is a managed Prometheus data source. So this is created just by a Grafana provider. We can point this data source to work with Prometheus, and even more convenient, you have this SIG-v4 authentication that actually allows Grafana to leverage the IAM role that it's running with to connect to Prometheus, and everything is done with least privilege. So it's only this Grafana that can work with only that Prometheus that was deployed for this specific cluster. Second thing is we decided to deploy 2 dashboards out of the box. One is for the admins. So this is Kubernetes cluster monitoring. This is one of the most common dashboards in Grafana dashboard site. And this is just show you the scale and capacity of the cluster in terms of memory, CPU usage, and file system, and all kind of things that are relevant for the deployment and management of the cluster. The second dashboard that we deploy is for the developers. So this will actually show you per pod metrics. So if we take a look here at our Nginx, we can actually see those are the 2 pods that we deployed. And you see that we deployed them recently. So we have some activity here on network and some CPU and a bit of memory. And this thing look like it's alive. All right. Now, I want to show you the OpenSearch. Now, OpenSearch, again, is deployed privately because we wanted to limit the access to the OpenSearch. And it's deployed inside of the VPC. Since we cannot access it directly, we're connecting to the Bastion host and doing the tunnel. So after I connect to this machine on port 10,443, I will have an access to this host, which is actually our OpenSearch Kibana. So let's connect to this host and let's open local host. So you can see we have our Elasticsearch here. And if I do dashboard, I actually get my OpenSearch Kibana. Now, if I go to discover, you can actually see that we already have a pattern for our Fluent bit, and we can see all kind of messages from Nginx and other containers. So it's all integrated out of the box. And this is the experience you should aim for when you're building the solution yourself as well. So let's close this window and let's disconnect from here. And this was the demo basically. So I will clean the stuff later. Let's go back to the presentation. Okay, so what are we planning next? First, we're definitely thinking about contributing back to open source. We probably will contribute to the EKS Blueprints modules. We learned a lot, and there's a lot of things that we feel we can improve there. And if it will make sense for the community, we will probably release our automation to set up Kubernetes as well. We're just looking for the right way to do it. We definitely want to add additional capabilities in terms of security that were recently announced, and we think they're super powerful. Stuff like guard duty for EKS, stuff like AWS Inspector for EKS, and we're considering to add KubeArmor as well. Even though it's not a managed service, this is very powerful runtime protection that is open source, and we're considering to add it as well. We also looking into improve the GitOps that we currently have. So as you saw, we already have the GitOps functionality with FluxCD, but we really want to provide this source to image functionality. When you can push your code into repository, we will identify the code with build packs, build the container for you without any Docker files, and push it inside of the ECR from where FluxCD will see it, update the Helm chart, and deploy it into Kubernetes. So the entire flow will be automated. This is current roadmap that we have. One last thing that I want to share is when you take the solution from the marketplace, we also provide it with a one-day hands-on training for the team. There are a couple of reasons we do that. One is to onboard the teams and explain them how to actually work with the Kubernetes and explain what they actually got as part of the solution. But the important thing as well is day to operation, how you can upgrade and maintain the solution that you get, and how can you work with Helm and GitOps with Flux. So you not just get something and automate it and that's it. You also get the convention, reasoning, and how to operate it behind the scenes. So I hope it was helpful, and I hope it got you a clue into how you can build it yourself as well. And if you have any question, me and Tsahi will be more than happy to answer them.
So there's one question on the Q&A. I think if you can, I can read it to you, and maybe you can address it. Yoni is asking, looks like you didn't add Istio to the cluster. Why?
Yeah, so two reasons. One, we were looking for managed solutions, and the closest to it is UpMesh. Second, most of the customers that are starting with onboarding to Kubernetes are usually not at the maturity level that they start with Kubernetes from scratch and go directly into service mesh, because there are complexities and penalties in performance. So this is currently what we do. We support UpMesh. This is something that is commonly not the first step that the customers do.
So another question from Yoni, is Istio existing in EKS Blueprint? I'm not sure Istio as the open source exists on the EKS Blueprint, but the Tetrate version of it exists both on EKS Blueprint and as a EKS add-on. There's another part of the EKS service that we haven't covered, which called like EKS managed add-ons, which basically manage the whole life cycle of deploying, upgrading, and managing add-ons in the cluster. We released a new feature which help you basically to onboard third-party or partners add-on into the EKS managed add-ons, and Tetrate is one of them, which supports Istio.
There's also console as part of add-ons, and this is additional service mesh that you can use in your Kubernetes.
Yeah, cool. Osher is asking, Carpenter is also efficient if used on-demand node group. Carpenter has no concept of node group. Carpenter reacts just in time to depending on the cluster. You can specify whether you prefer first to use Spot, and then if not, Carpenter has a mechanism to support like something like failover to on-demand, but of course it definitely provisions pure like only on-demand instances. Jack is asking, Lev, I think it's for you. Thank you for the feedback, by the way. How do you integrate the Terraform code with the application Helm chart deployed to the cluster?
So there are two things. Everything that we showed, like Fluent Beat and Carpenter and things like that, they are deployed as part of the EKS Blueprint, which is leveraging Helm module that originally was internal to EKS Blueprint, but now in version 5, as Tsahi mentioned, will be probably leveraged by just the general module. If you're talking about anything that you want to deploy yourself, you can either use Terraform provider for Helm, or you can use the module to do this if you're talking about your own software.
Cool. Last Q&A for now, but if you have more, feel free to write them down. Adina is asking, do you suggest building EKS with Terraform public module or configure it myself? I'm not sure what is configure it myself, like plain Terraform resources. This is usually a very, not a very, but like a complex way of achieving that. This is exactly why Terraform modules and infrastructure as code composition, as they call them, exist, and we highly recommend using the community add-ons, because it's also like a battle tested, well used by the community for quite a long time. But also it will be, as I stated earlier, it will be the focus of EKS Blueprint version 5 going forward. So,
and in general, there's always pros and cons if you want to use your stuff or leverage the community. EKS by now, I think 19.9 in terms of version. So it has a lot of experience behind it. A lot of challenges were addressed. So it's actually a very robust and a smart module that I think worth using instead of writing yourself.
Cool. Another question I will read it as it is and let's try to discuss about it. Is Helm good for managing using Helm chart? I understand it's not good as we don't have a good source of truth, as whenever we will run kubectl apply, it will change. Usually when you choose a tool or a process to deploy your application into the cluster, you should stick with it. Meaning, if you want to write plain manifest, plain Kubernetes manifest, that's fine. If you want to use Helm as packaging, that's fine. CDK, for example, is another open source that allows you to programmatically write actual code in your preferred programming language that will generate Kubernetes manifest. All of that, like at the end, generate Kubernetes manifest that will be applied to the cluster. So whatever you use, make sure you continue to use like the same approach. And this is also, like Lev mentioned, GitOps. This is also super relevant for GitOps, because if you, for example, manage Helm chart in a GitOps way and deploy the Helm chart to your cluster, if you do, let's say, for example, in your example was kubectl delete pods, the GitOps reconciler, whether it's Argo or Flux, because it knows to reconcile the Helm chart and not the manifest themselves, the pod will still be deleted. Like nothing will bring them back unless you delete the Helm chart itself. So my point is, whatever you use to manage your application deployment, you have to make sure you're consistently using, upgrading, updating this specific method, and not like mix and match for the same type of application.
For the same workload, it makes probably no sense to do that. You will just break the life cycle of it. If you're talking about different workloads, then it's a different story, right?
Yeah.
For everything that you bring from outside, Helm, whether you use it directly or through Terraform, makes a lot of sense. If you use your own software and you're not distributing it, maybe plain Terraform with Kubernetes manifest will make more sense for you directly without Helm, but this is like on a per case basis that you should decide that.
Sorry about that, but it's the it depends answer. So
yeah, exactly.
And Lev, I think this is for you. Do you use also TerraGrant?
Yeah, no. So we didn't use TerraGrant in this solution. First of all, everything that you saw is managed inside of one state for multiple reasons. One, to avoid complexity. Two is the number of resources is sufficient enough not to spread to additional states. So we kept it one state to just make it easier. And we didn't leverage TerraGrant to kind of orchestrate states or build dependencies.
Perfect.